Hi, in this video we're going to have a brief discussion on properties of definite integrals. So if you take any two integrable functions f of x and g of x and some constant k, then the following properties will always apply. So the definite integral from a to a of f of x dx will be 0. An integral from a to b of f of x plus or minus g of x can be rewritten as a definite integral from a to b of f of x dx plus or minus a definite integral from a to b of g of x dx. So you can basically split a sum or a difference. A definite integral from a to b of k times f of x, you are allowed to take a constant factor outside of the integral. So it's going to be k times the integral from a to b of f of x dx. Also, if you have an integral from a to b f of x dx, it's going to equal to an integral from b to a. So we switch the limits, so the upper limit becomes the lower limit and the lower limit becomes the upper limit, but then you have to negate that. So if you look at this, we switch the limits and we negate it. And finally, you're allowed to take any integral and split it into two integrals over any value of c. But please note, so we have a definite integral from a to b of f of x dx. So we're going to rewrite that as a definite integral from a to c of f of x dx plus a definite integral from c to b of f of x dx. So my initial lower limit has to be on the bottom here, and my initial upper limit has to be on top here, and c is going to be on top here and the bottom here. C can be anywhere. Alright, so let's go ahead and take a look at problems. So in example 1, we're given that an integral from 2 to 7 of f of x dx is 4, and the integral from 7 to 10 of f of x dx is -5, and we want to evaluate the integral from 2 to 10 of f of x dx. So what do we know? We know that the integral from 2 to 10 doesn't look like 10. F of x dx can be written as an integral from 2 to 7 f of x dx plus integral from 7 to 10 f of x dx, and we have each one of those individually, so it's going to be 4 plus -5, and it's going to equal -1. Okay. So the next problem is the integral from 1 to 5 of f of x dx is -3, the integral from 1 to 5 of g of x dx is 7, and we want to find the integral from 1 to 5 of f of x minus g of x dx. So we know integral from 1 to 5 f of x minus g of x dx can be, you can break up a difference, or if you have a sum you can do it too, from 1 to 5 f of x dx minus the integral from 1 to 5 of g of x dx, and we have each value, so it's going to be -3 minus 7, and that's going to equal -10. An integral from -1 to 4 of f of x dx is 4. Evaluate integral from -1 to 4 of 3 f of x dx. Okay, so we had a property there that allows us to take these 3 out. So what we're going to write is the integral from -1 to 4 of 3 f of x dx can be written as 3 times the integral from -1 to 4 of f of x dx. And we have this value here, it is 4, so it's going to be 3 times 4, and it's going to be 12. Okay, so far should be pretty simple. Let's take a look at some more examples. So we have an integral from 3 to 5 f of x dx equals -3, an integral from 7 to 3 of f of x dx equals 2, and we want to evaluate the integral from 5 to 7. So let's see, this one's from 3 to 5, this one is from 7 to 3, and this one's from 5 to 7. Well, so we're going to be able to say that, first of all, this integral here because this one goes from 3 to 5, this one goes from 5 to 7. So this one and this one together will give you an integral from 3 to 7. This one is an integral from 7 to 3. So what I can write is I can say that the integral from 3 to 7 of f of x dx equals the integral from 3 to 5 of f of x dx plus the integral from 5 to 7 of f of x dx. Correct? However, we have this integral here, but going from 7 to 3, right there, and it's 2. So if I switch the limits here, it's going to become negative 2. So this integral here from 3 to 7 f of x dx is going to be the opposite of this integral from 7 to 3 f of x dx. So it's going to be negative 2. Then what else do we know? We know that this integral going from 3 to 5 f of x dx is negative 3. And then we have plus, and this is the one that we're trying to find, integral from 5 to 7 f of x dx. So we're going to write that. Okay, so from this we can conclude, it's pretty easy to see, that the integral from 5 to 7 f of x dx is going to equal to 1, because you're going to do negative 2 plus 3, because you're going to add 3 to both sides. Okay. Example 5, we're given that the integral from 3 to negative 2 of f of x dx is 7. The integral from 3 to 7 of f of x dx is 5. We want to evaluate the integral from 7 to negative 2. So we have things slightly out of order here. And we want to see if we can figure it out. But I want to show you how we can actually handle. You don't necessarily have to flip the limits here. Here's what we're going to be able to do. We can say that this integral covers the most. It goes from 7 to negative 2. Because these two go inside of that. So I can write that the integral from 7 to negative 2 of f of x dx is going to equal to the integral from 7 to 3 of f of x dx plus the integral from 3 to negative 2 of f of x dx. Let me take a moment here and explain. So we got an integral going from 7 to negative 2. I'm allowed to take any integral and split it over any point and write it as the sum of two integrals. So I got an integral from 7 to negative 2, which I'm going to write as an integral from 7 to 3, and then from 3 to negative 2. So I start at 7 and I add at negative 2. We just have to look at what we have here. So this integral here we're trying to find. Correct? So we're trying to find the integral from 7 to negative 2 of f of x dx. Let's see what we know here. We need to have an integral from 7 to 3 f of x dx. We have the one from 3 to 7. So this one here and this one here are going to be opposites of each other. That means that this integral here is going to be negative 5. Plus, what about this one? This one's given to us. It's an integral from 3 to negative 2 f of x dx right there, and it is 7. So we do all this and we're going to get 2. Okay. And our last example here is we're given that the integral from 2 to 6 of f of x dx is negative 3, and we want to evaluate the integral from 2 to 6 of 2 times f of x plus 4. So we're going to have to rewrite that. So from 2 to 6 f of x, 2 f of x plus 4 dx. So that's going to be, this can be written as an integral from 2 to 6 of 2 f of x dx plus an integral from 2 to 6 of 4 dx, right? And you should probably know by now how to handle this, but the first integral we're going to have to take 2 outside, integral from 2 to 6 of f of x dx, plus this integral here is going to equal to 4x. So it's 4x evaluated from 2 to 6. Okay. For this integral we have this value, it's -3. So 2 times -3 plus, and here we use the rule that you probably know by now. So you plug in the upper limit first, it's 24. You plug in the lower limit then, which is -8. So plus -8 technically. And it's going to be -6 plus 16, and it's going to equal 10. Okay.